In lesson 3, we're going to take a look at half an equilateral triangle, investigating properties of altitudes of equilateral triangles, and it starts on page 138. So the first thing we're going to do in the first activity is sketch an equilateral triangle. Okay, so just draw yourself an equilateral triangle and draw an altitude from any vertex. Remembering that an altitude goes from a vertex to the opposite side and is perpendicular. Okay, so makes a 90-degree angle. And then what are some things you notice and what are some things you wonder? So pause the video, write down a few things, and then come back. So some things you might have noticed is that all of these angles are 60 degrees. You know, because it's an equilateral triangle, which means that it's also equiangular. So maybe you said the angles total 180 divided by 3 is 60. So each of those bigger angles is going to be 60. You could have marked the sides all as equal, right? Because they're equilateral, so you knew that. This 90-degree angle. Okay, maybe you wondered about this angle. Okay, or since the title of the lesson is half an equilateral triangle, maybe you wondered if the altitude splits the equilateral triangle in half. Are these two pieces identical? Maybe you didn't wonder how big this angle was. Maybe you actually figured it out by doing 180 minus 90 minus 60 and figuring out that it is exactly 30 degrees. Okay, these are all some different things you could have noticed and wondered. Plenty more you could have as well. That's just a few. So let's take a look at activity 2, okay, at the bottom of the page. So this activity gives you a equilateral triangle with an altitude drawn. So we see the altitude straight down the middle there with the 90-degree angle. Okay, so in fact, they have the angles labeled just like we talked about on the notice and wonder. And they have the side lengths of the equilateral triangle being 2. So go ahead and see if you can solve for x and for y. So pause the video. If you get stuck, come back. All right, so if you were stuck, one thing you might have looked at is that we see these two angles being the same. Okay, we know that the two triangles here share this middle piece, and we also know that this side is equal to this side. So if you remember back a few units, that means these two triangles are exactly the same size. Okay, they are congruent triangles by side, angle, side. So what that does for us is tells us that this piece is the same as this piece. And we know the total of this side length is 2, just like the other sides. So x needs to be half of 2. Half of 2, 1. Okay, so we know that this piece down here is 1. So then if we take a look at this red triangle that I've highlighted, okay, we know that that's a right triangle. So if you've figured out that this piece is 1, you want this piece, and you know that the hypotenuse is 2, you can use Pythagorean Theorem on that. Okay, so let me just draw a sketch of it over here. So we know that's 1, we're looking for this, and we want this. So we can plug that into Pythagorean Theorem. This is the hypotenuse. So we've got 2 squared is equal to y squared plus 1 squared. 2 squared is 4. 1 squared is 1. So we would need to subtract 1 from both sides to get y squared by itself. Then to get rid of this squared, we would square root both sides. So then we're going to get the square root of 3 equals y. And then you could certainly put that in your calculator and get that that decimal is about 1.73. So for this next activity, you're going to need to pick up a couple of things if you're in class. Okay, so you need a handout with 3 triangles, 3 equilateral triangles on it. And you need a dry erase marker because this is going to be in a sheet protector, so you can write on this with the whiteboard marker. And then you need a ruler. So I'm going to do an example of what you need to do on each of your 3 triangles. So this is not one of the triangles on your page. This is just me showing you what I need you to do. So you're going to take your ruler and you're going to measure these 3 different lengths. Okay, one of them being the side length of the triangle. Okay, so measure the length of each side. So this one on my page is 8 centimeters. Okay, I need you to measure the altitude. Okay, so go ahead and measure the altitude and get that written down. So that's about 6.9. So the altitude in each triangle. And then also the short leg created by the altitude. So you'll notice this kind of triangle over here. So the short leg, not the whole side, okay, just this short leg. So how big is that short leg? So for mine, it's 4 centimeters. So measure all of those in each of your triangles. Then you're going to look at some ratios. Okay, so it asks you to compare ratios of these sides. So specifically the ones I want you to look at in each of the triangles is I want you to look at the altitude divided by the short leg. Okay, so look at that ratio. What do you get when you do altitude divided by short leg? And what do you get when you do the triangle side? Okay, so the side length of the triangle divided by the short side. Okay, so the triangle side length divided by the short side. So for each of those 3 triangles, measure the altitude, short leg, and the side length. Okay, in all 3. And then do altitude divided by short and the triangle side length divided by the short leg. And look at those ratios. Then I want you to compare those and see if you can come up with a conjecture or something that you notice happening. So pause the video, get that done, then come back. Okay, so here's the measurements for each of those triangles. So you have triangle ABC, triangle DEF, and triangle JKL. So I've labeled the measurements, so you should have measurements close to that. So let's go ahead and look at some of the different ratios. Okay, so let's look at the ratio of the altitude divided by the short leg. Okay, so altitude divided by short here, so that was 6.4 divided by 3.7. And so you should have gotten 1.73 or 1.7. So let's look at altitude over short in each of these. Okay, so altitude over short in this middle one was 3.8 divided by 2.2. So altitude was 3.8, short was 2.2, and you get 1.73 again. And altitude divided by short here is 11.5 divided by 6.6. And you get 1.74. So then let's go ahead and look at the triangle leg divided by that short leg. Okay, so green divided by red. So 7.4 divided by 3.7. And so I'm getting 2 for that. In this one, it's 4.4 divided by 2.2, which is 2. And in this one, it's 13.2 divided by 6.6. And we're getting 2. So hopefully you're noticing that those divisions are very similar in each of these triangles, right? So 1.73, 1.73, and basically 1.73, and then 2, 2, and 2. So if you're taking a look at those, so what did we get for the ratio of the altitude, okay, to the short leg? So altitude to short leg, right, is this one. So altitude to short leg, what did you notice? And so we kept getting 1.73, okay, 1.73 each time for that. And then when we looked at the triangle leg to the short leg, we got 2. Okay, so when we divided those, we got 2. So the hypotenuse, or this longer leg here, okay, this triangle side leg here, is always 2, seems to always be 2 times the size. So if I take this times 2, I got that one. If I take this times 2, I got that one. And same with the short leg to the altitude, except for we'd be multiplying by 1.73. Multiply by 1.73. So if we take a look down here, so in a generalized setting, so this is the one we did before, okay, that we calculated before, do we think y is 1.7-ish times the size? So that would make sense. The red one times 1.73 or 1.7 is about what we're going to get. And remember, we got this was 1 and we got this was 1.73 when we calculated it. Okay, so it's approximately 1.7 times bigger. It is exactly square root of 3 times bigger. So when we figured it out, we got y was the square root of 3. This is the exact answer. And then the approximate decimal is 1.7 or 1.73. So that's the rounded version, or about that many times. So let's use this in a couple examples. Okay, so let's use this in a few examples. So these examples are at the bottom of page 139. So this is half of the equilateral triangle. We know because we see this 60-degree angle. So then remember, this is going to be a 30-degree angle. So what we know about that is then that this is the altitude. Okay, this is that shorter leg. And the hypotenuse is the longest leg, or the leg of the triangle. Okay, so this makes sense. We see that this is half of an equilateral triangle. So here's the triangle leg length, and then this is half of it. So now use what you learned to go from short to the altitude. So what was the relationship we just saw there? So multiply by 1.73 and you'll get that altitude. So the altitude equals 5 times 1.73. So we take that short leg and multiply it by 1.73, or by the square root of 3 for an exact answer. Okay, so we should probably actually put in square root 3 since we're using calculators. Okay, so type in 5 times the square root of 3. And you'll get 8.66 or 8.7. So in this next one, again, we see a 90-degree angle and a 60-degree angle. So we know this one is 30. So we know it's half of an equilateral triangle. This time they just gave us the short leg. So we just did this over in the first problem. Okay, and you can pause the video in between these to try it yourself. But we've got the short leg. So how do we get that altitude? So you're going to multiply by square root 3. Okay, so the altitude is going to equal that short leg times the square root of 3. So if I just remove that multiplication symbol and I just write these right next to each other, that would be your exact answer. You could just leave it just like that. Otherwise, if you type it in your calculator, 3 times the square root of 3, you'll get the approximate answer of 5.2. And then how did we figure out this side? Okay, so that's double the short side. So we've got the short side times 2 gives us this one of 10. Third example, so give it a try. Come back and watch when you're done trying. So this time they give us the altitude. So remember, previously we've gone short times the square root of 3. So how do we go backwards? Okay, so going backwards would mean that I need to divide by the square root of 3. Okay, so we're going to take 2 square root 3 and we're going to divide by square root 3. So guess what? Those will just cancel. Square root 3 divided by square root 3 is 1. So we just get that this short leg is 2. And once you have the short leg, you can find this hypotenuse because it's just 2 times this short leg. So this is just going to be 4. This short leg times 2. So let's generalize this. Okay, so I would, these kind of show up in your summary on page 141. So on the back of your summary, this one does actually. But these are the 2 triangles that we've kind of looked at over the last 2 lessons. So remember, if it's a 45-degree angle, a 45-degree angle, and a 90-degree angle, that means that it's an isosceles triangle. And so your legs are always going to be the same. So these are the same length. And then the hypotenuse is square root of 2 times bigger. So if you have the legs, you take them and you multiply by the square root of 2 to get the hypotenuse. So we would take the side length, we would multiply by square root 2 to get the hypotenuse. If you have the hypotenuse and you want to get to the short leg, then you would want to divide by the square root of 2. Now, if we have a triangle that has a 30-degree angle, a 60-degree angle, and a 90-degree angle, then the proportions, okay, are slightly different. So you've got the short leg, okay, so this one, it's across from the 30-degree angle every time. So where you see the 30-degree angle, that short leg will be directly across from it. So that short leg, okay, if you have that, you can multiply it by square root of 3 to get the altitude or the longer leg. Okay, so to get this one, multiply by square root 3. And to get the hypotenuse here, you would multiply that short leg by 2. So that's why you see this 2 times x, x being the short leg, x times the square root of 3. So multiply by square root 3 to get the long leg, multiply by 2 to get the hypotenuse. And then the backwards version of that, if you have the hypotenuse, okay, to go back to the short leg, you would divide by 2. If you have the long leg, you would divide by square root 3 to go backwards. So let's take a look at that in the summary. So here's a couple of things. Okay, so the big deal here is that it has to be 30, 60, 90 degree triangles. That has to be the angle measures. So if the short leg is 1, the altitude is square root 3, and the hypotenuse is 2. This is kind of like a parent triangle that you can always compare it to. So every other 30, 60, 90 triangle is a dilation of this, okay, just bigger or smaller by a scale factor. So if we go down to these examples, okay, so this short leg, if we just call it y, meaning any number, the long leg is going to be times by the square root 3, the hypotenuse is going to be times by 2. So how do we go backwards from that? If this is 5, okay, so this is 2y, divide by 2 to get to this. So we would divide by 2 to get this side. So this would be 2.5. Or if you just want to see what you did, instead of writing the decimal, you could just write it as 5 divided by 2. Then how do we get this altitude? Okay, multiply by square root 3. So we have this y. This needs to be that number times the square root of 3. So whatever this leg is times the square root of 3. So what if we have the altitude already? Okay, so we have this. How do we go back to that? Divide off this square root 3. So when we want this side, we would take the 4 divided by the square root 3. Which then if we have this shorter leg, okay, then we can multiply it by 2. So 2 times that amount is our hypotenuse. And you could type this in your calculator. I'm just going to multiply the 2 in, so it'd be 8 divided by the square root of 3, but you can certainly put that in your calculator for the decimal version as well. All right, so make sure you have that highlighted on your summary, written down. Okay, and I would make sure that you have the 2 kind of main triangles that we talked about identified there. So these 2 triangles, let me grab them. And I would put those at the bottom of your summary. Okay, your summary goes on to 2 pages. So I would get these written out. Okay, so that you have these so that you can identify them and use them.